going to work with number 73 from the section 1.3 homework on quadratic equations. So number 73, it's the following formula. You have h is equal to 1/2 times g times t squared. And the goal is to solve for t. That's why I wrote it in a different color so we can kind of focus on it. So we're basically just going to go ahead and continue to do what we've always done. We're going to use the idea of inverses in order to help us clean out the right-hand side of the equation and get t by itself. So one of the first things that I would suggest doing is, well, you can kind of pick. I would suggest going ahead and multiplying both sides by a 2, because if you notice, you would have a 2 in the numerator and a 2 in the denominator, so that would clear out that 1/2 on the right-hand side. So this is going to give us 2h is equal to g times t squared, and I should be a little bit more consistent and make that t pink. Okay, so now ask yourself, okay, on the right-hand side I have g times t squared. Well, how can I start getting t by itself? What would be one of the easier things to do or undo? So notice that g is being multiplied by t squared. So we can undo that multiplication by division. So those go out. And now what we are left with is we have 2 times h divided by g is equal to t squared. So the last thing that we need to do is we need to get rid of that squared. We need to get rid of that exponent. So what we can do here, and hopefully most of you are thinking it, you're probably saying, well, why don't I go ahead and hit it with a square root? And I would completely agree with you. So we would see here that we have the square root of 2 times h over g is equal to t. So maybe you got this far and you checked in the back of the book and you were saying, shoot, this does not look like the final answer. Well, here's what they did. They actually cleaned it up a little bit. They rationalized the denominator. Okay, so I'm going to rewrite this. I'm going to give the numerator the square root, and I'm going to give the denominator the square root. And this is perfectly legal to do. Okay, so I need to figure out a way to rationalize the denominator here. And my main concern is that how many g's do I have underneath that square root right now? And you should be saying, well, I only have one of this variable g. How many g's would I need in order to break out of this prison? Well, since the index here, since I don't see it, it means that the index is 2, and that means that I would need to have 2 g's in order to break out. So what I'm going to do then is I'm going to multiply both the top and the bottom by a square root of g. The reason why I'm doing that, 1, this will rationalize the denominator for me, and 2, the reason why I'm multiplying both the top and the bottom by the square root of g is because I don't want to change the value. So if I multiply the top of the fraction and the bottom of the fraction by the same value, I'm essentially just making it look bigger. I'm multiplying it by a glamorized 1. I mean, in this case, do you guys agree that the square root of g over the square root of g is really just 1 if you were to simplify it? See what I did there with my nifty art skills? Okay, so what we're going to note here is that now if you have the square root of g times the square root of 2h, this would become the square root of 2 times h times g, because inside numbers can be multiplied with inside numbers. On the bottom, we would have the square root of g squared. This is all equal to t. Do you see what's happening? Let's kind of give ourselves a little bit more space. Well, I have the square root of 2 times h times g over, oh look, the square root and the square cancel each other out. And here is the solution that was presented in the book. They were following the rules that when we present our answers, we do not want to have a radical in our denominator. So in order to clear that out, we rationalize the denominator. If you feel that you need additional practice with rationalizing the denominator, please let me know and I will provide those additional resources for you on the D2L site.